Hello everyone, my name is Rohit Singhal and we were discussing about redox reactions. Till now we have studied that redox reaction are comprised of two things, one is reduction and another is oxidation. We have separately dealt initially with the two terminologies, that oxidation means addition of oxygen or any electronegative element. Similarly, removal of hydrogen or removal of any electropositive element. Reduction then we have discussed is complementary to that oxidation reaction, that means in reduction reaction addition of hydrogen or any electropositive element or removal of oxygen or any electronegative element. We have discussed this. Then we have said that every reaction has a basis of basis by the electron transfer thing. So, we have discussed the redox reaction in terms of electron transfer. What we have said is we have taken the case of sodium reacting with chloride to give NaCl. What we have said that sodium is, yes, it has been attached with an electronegative element. So, it is an oxidation reaction, but what is happening to sodium, that sodium initially has a 0 charge in the reactant side, right. Where it forms NaCl, it forms a +1 charge. We know from chemical bonding that NaCl can be best represented as Na plus and Cl minus. So, what sodium is doing? Its sodium is actually losing one electron, and sodium we know is getting oxidized. Okay. So, we have in terms of electron transfer, we have described oxidation and reduction reaction, that is oxidation has been loss of electrons. Whenever there is a loss of electrons, that is termed as oxidation reaction. Similarly, for reduction, Cl2 initial charge is 0, afterwards forming NaCl it forms -1, that means it is gaining electrons. Okay. That means, a reduction reaction has been termed as gain of electrons. So, what we have studied for the redox reaction in terms of electron transfer is that oxidation reaction is loss of electrons and reduction reaction is gain of electrons. Both the reactions combinedly goes with each other. You have seen that sodium is getting oxidized and chlorine is getting reduced, that is called reduction reaction. This complete reaction Na plus Cl2 gives NaCl, I have discussed, this is called complete reaction. This is a complete reaction where both oxidation and reduction have been shown. However, just to simplify for our case, what we normally do is we study this complete reaction into two halves. We know that reduction is a combination of two things, reduction and oxidation. So, what we normally do is to just simplify the equation. What we do is we separately read the oxidation part, we separately read the reduction part, and afterwards discussing it, then we combine it. The upper one, the complete reaction, which I have shown earlier, is also to you, that is sodium Cl2 gives NaCl. This is called a complete reaction. Why this is a complete reaction? Both oxidation, or this is called complete cell reaction, complete cell reaction. Both oxidation and reduction processes are shown. Okay. So, why this is an complete cell? Because both the process has been shown. What we do for our simplification is we separately study the oxidation part, this is oxidation part known as oxidation half cell. That means, we divide our complete half cell reaction into two half cells. What we do, we complete half cell reaction, because complete cell reaction, because both oxidation and reduction are happening. So, we divide that complete cell reaction into two equal halves, that is called half cells. The one is oxidation half cell, where we discuss which element is getting oxidized, and the other one is reduction half cell. Okay. Till now, from the previous classes we have discussed this. Now, one thing to take care of in this thing is taking the same example. Okay. You must see, you have also studied this from chemical bonding, that the sodium is losing one electron. Okay. Sodium losing one electron, Na forms Okay. This sodium, you must know, you know from the chemical point of view, this sodium can't lose electron on its own. I mean, there should be something that prompts sodium to lose the electron. Okay. Sodium, any element don't lose electron on its own or gain electron on its own. There should be some driving force to for any electron transfer process. Okay. So, what is the driving force here in this R case? This sodium, why this sodium is losing one electron to form NaCl? Why this Cl2 is gaining electrons to form NaCl, a more stable complex, an ionic complex, a stable complex, you know, ionic compound, let us say. So, what is the driving force to form a stable compound? Okay. But how sodium is actually losing electron? What is prompting sodium to lose electron? Formation of NaCl. Who is responsible for this loss of electron is presence of chlorine. The presence of chlorine prompts sodium to lose electron, because if an element is losing an electron, there should be the other one to gain that electron. Similarly, if someone is gaining something, it will gain from someone, na. If there is someone to give the electrons, there will be someone to take the electrons. So, both this sodium and chlorine in presence of each other undergoes an electron transfer process to form an ionic compound. What I mean to say here is that whatever element is getting oxidized, okay, what is responsible for that element to be oxidized? The element that has been reduced. Okay. So, if I am saying for sodium to get oxidized, Cl2 is the, we say, okay. Sodium is losing one electron. Why? Because there is chlorine, it is prompting sodium to do it. That sodium is acting as an agent. Sodium is acting as an agent for sodium to lose its electron. Okay. And what sodium is doing? Sodium is getting oxidized. So, we are saying that sodium is getting oxidized, and then once what Cl2 will be called? Cl2 will be called oxidizing agent. So, there are two new terminologies we are going to discuss. One is, okay, okay, this is getting oxidized. Who is enabling this sodium to get oxidized? Is this agent, chlorine, that acts as an agent, to for sodium to get oxidized, and that is why it is called, and that is why okay. Keep this thing in mind, that sodium is getting oxidized, chlorine is acting as an agent for sodium to get oxidized, to lose electron. That is why chlorine is called oxidizing agent. Similarly, we know that chlorine gaining electrons to form Cl minus. Why the sodium is, from where the sodium is getting electrons? Sodium, What is prompting sodium chlorine to gain electrons? Sodium. That means, similarly sodium is an agent, sodium acts as an agent I am saying similarly sodium acts as an agent for chlorine to gain electrons or to get reduced. Okay. That is why we will say sodium is what? This sodium is what? Reducing agent. Okay. That means, whatever element or part is getting oxidized, what is responsible for that oxidizing part is the other part that is getting reduced. So, the part that is being reduced is called oxidizing agent and the part that is being oxidized is called reducing agent. This might be a bit confusing, but you just understand that how why this agent term is been coming from, okay. And you will be able to better understand these things. So, two new terminologies I have told you is, okay, let us combine all the terminologies. One I have studied oxidation reaction, oxidation, okay. The another one is reduction, third one is oxidizing agent, and the fourth one is reducing agent. Okay. These four things are there. Oxidation I have told you loss of electrons. Reduction, gain of electrons. Okay. Oxidation is loss of electrons, reduction is gain of electron. What is oxidizing agent? Oxidizing agent is the same element that is been reduced, it is opposite. Just remember in this sense that whatever element is getting reduced, it is only responsible for the other element to be get oxidized. So, oxidizing agent is same element which is getting reduced. The element that has been reduced is only known as oxidizing agent. Okay. And which element get reduced? Element get reduced, that means acceptor of electron. That means whichever element accepts electron is responsible for the other element which is getting oxidized. Let us say chlorine is responsible for sodium, because sodium can only lose electron when there will be someone to gain electrons. So, chlorine is responsible for sodium to get oxidized. Okay. So, chlorine is accepting electron, there is an acceptor, sodium is let us say donor. What sodium is? Donor of electrons. This is same element which is getting oxidized, and this is okay. The element which lose electrons is oxidation, the element which is accepting electrons is reduction. Okay. And the element which is accepting electrons is called oxidizing agent, and the element which is donating electrons is called reducing agent. Simple. This you have to study, or this you have to keep things in mind, a bit complementing a bit maybe complex. So, just take care of these things in mind, that acceptor of electron and donor of electron, and the element which gets oxidized is the reducing agent, and the element which gets oxidized is the reducing agent. It is totally opposite, just keep these things in mind. There have been a few problems in NCERT that I will discuss just to for your better practice. Problem 7.1 there is, one reaction is given, that is H2S plus Cl2 forms 2 HCl plus sulfur. Now, what I have been asked is ki identify whether these reactions identify the species which is going under oxidation and which is going reduction. Okay. So, let us see species number 1, H2S. What is happening to H2S? Let us say sulfur. Sulfur is, there has been removal of hydrogen. What is happening? Removal of hydrogen. And what is removal of hydrogen? Removal of hydrogen is reduction reaction, sorry, oxidation reaction. Cl2, hydrogen has been added, addition of hydrogen, reduction reaction. You will find both the thing, oxidation, reduction, both the things in only one reaction. You just have to identify the species which is getting oxidized, which is getting reduced. There is one another example. Sodium, let us say species number 1, sodium. What is happening to sodium? Addition of hydrogen, that is reduction. Addition of electropositive element, sodium, that is electropositive element, that means okay, no, there has been some mistake. Okay, sodium and hydrogen reacting with NaH. Okay. So, what we seeing in this, sodium is going from plus 0, we know Na plus H minus, plus 1 and H minus. Okay. So, this sodium is going from 0 to plus 1, that means oxidation, okay. And this is 0 to minus 1, that is gain of electrons. Okay. So, you must be wondering that why earlier I have written the wrong thing. This is because of the thing that this sodium, this is you say that addition of hydrogen is getting there. There is not the addition of electropositive atom. This hydrogen, there is an addition of H minus. Addition of H minus is happening, not H plus is happening. Okay. Just take care of this thing. So, better whether defining any species, whether it is going under oxidation or reduction, better to see it in the perspective of electron transfer, that it is going from 0 charge, plus 1, minus 1, that you will able to better comprehend it whether the reaction is oxidation or reduction, because that might be confusing otherwise, H plus, H minus, you do not have to see all those things. You just see that whether it is getting plus charge or it is getting increase in charge or decrease in charge. Okay. So, always so keep this thing in mind, that see the reaction to whether the it's going oxidation reaction in terms of electron transfer thing. In the next class we will discuss about whether if let us say two elements are there which both want to oxidize, then which preferably will be oxidized first or reduced, that we will see in the next lectures. Thank you so much.